So specimen you can keep this way also, doesn't matter either way, both way you can keep, this way also you can keep, doesn't matter, right? So I am going to keep this way, that is my convenience, right? So here taper is that, this is taper surface, not flat surface. So here I need to make exact flat surface, it should be flat, parallel to base, right? Right now it's not parallel to base, right? I need to make it parallel. So what I have to do? Here height I have to increase gradually, right? So what you have to do is, first of all, you can take any value you can take, okay, approximate value. Then where you have to place slip gauge, so dimension below this roller, right?
Yes, sir.
Then manually you can check whether this parallel surface or not. Some variation may be there because we cannot set exact parallelism, right?
Yes, sir.
Then what I am going to do is, here you can set extreme and you can set dial gauge. Extreme and this is similar to same thing, 4, right? 400 micron. Then make it coincide with 0. So right now initial value is 400 micron, right? Then you can move along the surface. So some deviation you can see, right? Sometimes it will be positive deviation, sometimes it will be negative deviation. So extreme and what is the deflection? Extreme and what is the value? Initial value, what you said is 400, extreme and this side, right? Left side what you said is 400 micron. Then you can move along the surface. Extreme and what is the deflection you come to know, right? Right now we cannot see because it is above turn. So within limit you have to set, right? So what I have to do is, this pressure, initial pressure I have to decrease. So what I am going to do is, here I am going to reduce pressure. Now showing exact 2, right?
Yes, sir.
So 200 micron. Again check deviation. So this is within limit.
Yes, sir.
We can see the reading, right? If it is out of limit, what you have to do is, slip gauge value you have to change. Slip gauge value you have to change, right? So here we come to know what is the initial reading, then what is the final reading. So the deflection you can take. What is the difference, right? Final value minus initial value. So we will be getting some difference, right? Then you can add or subtract from H value.
Slip gauge.
Because slip gauge value, example this is 9, you have to add or subtract that particular deflection, right? Actual deflection you have to find out.
Yes, sir.
You have to subtract final value minus which one is positive you have to take, right?
Yes.
Higher value minus lower value, you will be getting deflection. Then you have to add or subtract from actual value. So then you can assume that there is a parallel surface, right? So you will be calculating what H value. Then you can apply sine trigonometry. Sine theta is equal to H by L. Opposite side divided by hypotenuse, right? Then sine inverse is equal to theta is equal to sine inverse H by L. You will be getting value. Theta. Okay. That's all. Same.